In this video, we're going to suppose that f of x is equal to x minus 2 multiplied by x minus 4, and g of x is equal to x minus 6. Now we want to use that information to answer three questions. First of all, we want to know what f divided by g of x is equal to. Then we want to know what f divided by g of 5 is equal to. And then finally, we want to know what the domain of f divided by g of x is equal to. So let's go ahead and look at this first problem, f divided by g of x, and we're really going to have to do that one before we can do the other two anyway. So that's a great starting point. So in its current form, we're looking at this right here, f divided by g of x is kind of confusing if you look at it, and you may not know exactly what to do. And so that's why I recommend just rewriting the problem so that it's not in this confusing notation. F divided by g of x really is the same thing as f of x divided by g of x. And just rewriting it like that kind of gives some insight into the strategy for solving this problem. It's just easier to deal with. If you look at this way, then you can say, okay, well, f of x is equal to x minus 2 multiplied by x minus 4. So all we're doing is switching out the f of x right here for what it's equal to there. And then we're going to put that over in fraction form, g of x. Well, we know g of x is equal to x minus 6. And again, all we're doing is switching out the g of x for what it's equal to. And that's your answer. That's all you have to do. So when you're doing the quotient of two functions, usually the answer is going to be pretty straightforward. You just put one function of the other. You want to look and see if there's anything you can do to simplify. So if we had any common terms on top and bottom, and it was all like multiplication, you could look to, cross off those common terms, or if you could factor something out. You always want to look for those sorts of things. Anyway, you can simplify the answer. But in this case, there's nothing we can do. So we're just going to put a box around x minus 2 multiplied by x minus 4 all over x minus 6. That is the answer for the first part. So now the second question is we want to know what the f divided by g of 5 is equal to. Well, we already found the f divided by g of x, and that's just what we put a box around. So the f divided by g of 5, that would just be where we put a 5 in the place of x everywhere we have an x in what we just found for the last problem. And so instead of x minus 2, we would have 5 minus 2. And that would be multiplied by, instead of x minus 4, that would be 5 minus 4. And that would be all over. Instead of x minus 6, that would be 5 minus 6. So all that's doing is plugging 5 into the thing we found for the last problem. And then we can just simplify this piece by piece. 5 minus 2 is going to give us 3. 5 minus 4 is going to give us 1. And in the denominator, 5 minus 6 is going to give us negative 1. Of course, 3 times 1 is going to be 3, divided by negative 1. That's just going to give us negative 3. And so that's the answer to the second question. So anytime you're doing the algebra of functions, and first of all, you have to find either the addition, subtraction, multiplication, or division of two functions, you can find that. But then if you need to plug in a number, you don't have to go back and find the f of 5 and then divide it by the g of 5. What you can always do is just plug in whatever it is you're looking for into that algebra of functions, in this case the division of the two functions that we found before. So it's kind of like, steps. You do one step and then you can build on that foundation to make the second part easier. So that's the answer to the second question. Now the third question is a little bit different. We want to find the domain of the f divided by g of x. So remember, f divided by g of x, that was the answer to the first problem that we did. That was x minus 2 multiplied by x minus 4 all over x minus 6. And so the types of things you want to look for when you're interested in the domain is you want to look for things that could cause there to be a 0 in the denominator. Those are excluded values. We have to toss those out. You also want to look for things that could cause there to be a negative number under square root. And really that's all we've talked about so far in this class of things that would violate a domain. Well, here we don't have any square roots, but we do have a denominator that has a variable in it, and that can't cross out with something on top. Even if it did, it wouldn't matter. You'd still have to set each of the factors in the denominator equal to 0. And so what we're going to do is we're going to set x minus 6 equal to 0. That's just our denominator. Remember, we don't want that to equal 0. And so that's why we're setting it equal to 0 to solve for that excluded value. So just add 6 to both sides, and we're going to get x is equal to 6. And so that's going to be an excluded value. So we want to include everything except for that. And so when we write out the domain, we're going to say the domain is equal to everything from negative infinity all the way to 6. And then we're going to pick up on the other side of 6 and go to positive infinity, because that's the only value that we want to exclude from our domain. So it's going to be all real numbers except for 6. So that's it. Typically, finding the quotient of two functions is pretty easy, but you're going to want to take into account what sorts of constraints you cause to happen on the domain, since you are typically going to be dividing by a function of x. So that's it.